Okay, welcome back, and now we're going to do an example of using the law of cosines. So again, I always draw a picture. Most of the time you draw a picture. You don't have to draw a picture. If you just use the formulas and just solve for each of them, you can do that. But again, you can also draw a picture. It doesn't matter what the picture looks like. It might be completely off. Okay, so A, that's going to be this side, B, and C. And so now A equals 22.8, right? So that's 22.8 centimeters. 12, or B is 12.3, 12.3 centimeters. C is 42 degrees. So notice we have the sides and the angle between them. So 42 degrees. So now what are we going to do? Well, let's use the law of cosines to solve for this side, right? We're going to solve for the side opposite the included angle. Okay? So C squared is going to equal A squared plus B squared minus 2AB cosine C. And so we know all of this. So it just becomes what? 22.8 squared plus 12.3 squared minus 2 times 22.8 times 12.3 times the cosine of 42 degrees. And we can stick this in our calculator and we get C squared is equal to approximately, let's see here, it's about 230, I think, something like that. But again, if we take the square root, right, if we take the square root, we end up taking the square root of this whole thing, right? And if we take the square root of this whole thing, we get approximately 15.95. So approximately 15.95, or approximately 16. So, but I'm going to go out one decimal place. So 15.9 centimeters, since both of these are out to one decimal place. Okay, so that's C, right? Now, what else do we need to solve for? Well, we got C, but now we got to get A and B, okay? Now, at this point, we can use the law of sines. We don't need the law of cosines anymore because now all we have to do is solve for A, and then B, we could just use the fact that the three angles have to add up to 180 degrees. So let's do that. Okay, so let's use the law of sines to solve for that. Okay? So we got C. So C is equal to 15.9 centimeters. Okay, so let's erase this. I already got my triangle filled out, so let's go on. So let's do what we're given. So let's do sine C over C is equal to sine A over A. And so now we get sine C over 15.9 equals sine of A, oops, this should be sine 42 degrees, sine A over 22.8. Okay, and so now we solve for sine A. So that means sine A is going to equal 22.8 times sine of 42 degrees divided by 15.9. And of course, just you stick that in your calculator, and we get let's see here. We get A is about 106.9 degrees. Well, actually, let's go one step further. So this would be A, right? If we take the inverse sine of both sides. So this would be inverse sine of this whole thing, which is 22.8, right? Times sine of 42 degrees divided by 15.9, and that's going to give us about 106.9 degrees. Is that right? Is that what I get? Yeah. Now, here's the thing. I didn't have to use the law of sines to get this. I could have also used the law of cosines. Okay? Because now that I got C, I can use C and A, right? And solve for cosine A. Or in fact, if I wanted to solve for cosine A, I'd need these two, right? So I can use these two and solve for this angle here, because then I would have what? I would use, just so you show you, I would use A squared equals B squared plus C squared minus 2BC cosine A. Well, I know A squared, right? I know A. I know B. I know C. I know the only thing I don't know is cosine A. So I could solve this for cosine A and then take inverse cosine of both sides and solve for A the same way. Okay? It's totally up to you. You'll get the same answer. Okay? And then to get the final angle, all I have to do is use the fact that 42 plus this plus B has to add up to, they have to add up to 180 degrees. So if I take 106.9 degrees plus 42 degrees, that's going to give me 148.9 degrees. And so angle B is going to be the, well, I'm going to subtract that from 180. That's going to give me 31.1. So this is going to be 31.1 degrees. And that's it. So I got, this is 106.9 degrees. There you go. And I solved the triangle. Have a great day.